guys, Mr. Adamson here. We are going to talk about today some of the basics of factoring polynomials. So I'd like to get us started today by thinking about what we did last class, and that was dealing with distributing two binomials. If you recall, what we're going to do here is we're going to take this first term, this x, and we're going to distribute it to the other x and also to the 3 that's in that second expression over there. So x times x is going to give us x to the second power, and x times 3 is going to give us 3x. And then we're going to do the same thing with the negative 2. We're going to distribute this negative 2 to the two terms over there in the second binomial, and that's going to give us negative 2x, and negative 2 times 3 gives us negative 6. Of course, we're not quite done yet. We've got to look at this expression here, and we're looking to see, do we have any like terms here? And of course we do, because 3x and minus 2x have the exact same variable, making them like terms. And when we have like terms, we like to combine them. 3x take away 2x is, of course, just 1x, or x. And everything else is going to stay the same here. So that's more or less where we were a couple classes ago, and last class as well. And we talked about this process, and we talked about it going like this, and we called it distribution. That's what we were doing here. We were distributing one binomial to another binomial. But of course, just like everything else we do, we need to have a mechanism for going the other direction. We need to be able to take this x squared plus x minus 6, and we need to be able to go back. We need to be able to go back to the factored form of this expression. And that's really what we're going to focus on today. We're going to look at some simple methods for taking an expression that is in simplified form, like this right here, and we're going to move it back into factored form, like this right here. So here we have a pretty simple example of a trinomial, in this case, that we'd like to go ahead and factor. So what we're going to do is we're going to follow a pretty easy process where we start by looking at the constant term. And if you remember, the constant term here is the term that does not have any variable attached to it. In this case, it's the number 8. And we're going to create a little chart over on the side of our paper, and on the top of that chart, we're going to write that number 8. And our first job here is to think about what are some ways that we can factor the number 8. Well, let's think about it. What numbers go into 8? Well, certainly 1 goes into 8. And we can certainly write that down. 1, and what times 1 is going to give us 8? Of course, just 8. 1 times 8. And when we think about other numbers that potentially go into 8, the only other one that we run into here is 2 times 4. There's a nice set of factors there, 2 times 4. So there's really two factorizations of 8, either 1 times 8 or 2 times 4. And what we're going to do here to kind of choose between our factorizations is we are going to go to the middle term here. We're going to go to our linear term, that is our term that has just the variable without an exponent right there. In this case, it's 6x. And we're going to think about, if we look back over at our factors, do any of our factors add together to give us that 6? Well, 1 plus 8 is 9, so that's certainly not going to work for us. But 2 plus 4 is 6. And because that 6 is equal to our middle term, we're going to go ahead and select those factors right there, 2 and 4. And then writing this in factored form becomes pretty easy. All we're going to do is set up 2 parentheses. And of course, the only way to create an x squared is to multiply an x times an x. And the best way to create that 8, according to our chart over here, is to go ahead and choose a plus 2 and a plus 4 for our factors. Now let's take a look for a moment and see, does this actually give us the expression we want it to give us? And of course, to check that, we're just going to work backwards. We're going to distribute our expression. X to x gives us x squared, and x to 4 gives us 4x, and 2 to x gives us 2x, and 2 times 4 gives us 8. And when we go looking for those like terms in the middle, that 4x and that 2x, we get x squared plus 6x plus 8. That is indeed the exact same expression that we started with. So that would imply to us that this is the correct factorization, x plus 2, x plus 4. So I'd like to look at another example here, a pretty simple example. We're going to look at x squared plus 7x plus 12. But I'm going to go ahead and give you guys a chance now, just thinking about what we just did a moment ago with looking for the correct factors. I'd like to see if you can factor this on your own. All right, so I'm sure you gave this a good try. I'm going to walk through it anyways with you guys. I want to make sure that we're all on the right page here. And so if you recall, our first step here was identifying the constant term, the term that doesn't have a variable. In this case, the constant term is, of course, 12. So we're going to create a nice little t-chart over on this slide with the number 12 in it. And when we start thinking about factors of 12, there's really quite a few we could pick from. We could pick something like 1 times 12. We could pick something like 2 times 6. Or we could even pick something like 3 times 4. And we notice here as I go, I went 1, 2, 3. The next number I would get to would be 4. And since I've already created a factor that has 4 in it, I know that I've completely factored that number 12. There are 3 possible ways to factor the number 12, and I've written them all down here. So second, we're going to go ahead and we're going to look at that middle term. We're going to look at that linear term, that is 7x. And we're going to say, do any of our factors that we've just created add up to 7? Well, 1 plus 12 is going to give us 13, so we know that that's not going to work. And 2 plus 6 is going to give us 8, and we know that that is not going to work. 3 plus 4, however, is 7, and that goes ahead and adds up to that middle term that we are looking for. Therefore, 3 and 4 are the factors that I am interested in for creating this factorization of this trinomial sitting here. And we're going to set up 2 parentheses. Again, we're going to say that the way that we build an x squared is by x times x. And of course, the factors we chose to best create the number 12 were plus 3 and plus 4. So far we've dealt entirely with situations that require simply using positive numbers. And in this question, for the first time, we start to see that sometimes we're going to have subtraction in our polynomials. And as we look here at our constant term in this particular question here, we're looking at this whole term right here, and that is negative 24. So when we create our little t-chart over on the side, we're not just going to put 24 in that chart, we're going to put negative 24. And the process for creating factors here is going to be exactly the same as it was with positive numbers, but of course now we've got to think a little bit about negative numbers as well. So as we start going through this process, let's look for some factors here. So I know I can multiply 1 times negative 24. And I know that I can multiply 2 times negative 12. And 3 times negative 8. And 4 times negative 6. And 5 doesn't go in. And then by the time I get to 6, I'm going to start repeating some of my factors. So we're looking at this list. We know that we're trying to add up to the number 2. And as I start to add these together, I see this first line, 1 and negative 24 adds up to negative 23. And that's not going to work for me. And 2 plus negative 12 gives us negative 10. And that's not going to work for us. And 3 plus negative 8 gives us negative 5. And that's also not going to work for us. And 4 plus negative 6 gives us negative 2. And alas, we see that that doesn't actually work either. It's really close. Negative 2 is the opposite of what we are looking for. But what we're really looking for is a positive 2. So we've got to think, what can we do with the factors we've created that would actually allow us to get a positive 2 instead of a negative 2. And the solution's pretty straightforward. All we're going to do is, instead of choosing a positive 4 and a negative 6, we're going to choose a negative 4 and a positive 6. And that's going to end up still multiplying together to give us the negative 24, but it will add up now to a positive 2, making that our best choice for factors for this particular polynomial. When we go to set up our factors, once again, we're creating an x squared by multiplying x times x, and we're going to create our negative 24 by multiplying negative 4 times positive 6. So I'm going to take a moment right now, and I'm going to ask for you to try to do one of these questions. I want you to try to deal with your negative answers, and we'll take a look on the next screen to see if you got it right. So let's check and see who got this one right. Once again, we're going to start by grabbing that c term, that constant term, that negative 18, and we're going to throw that in a t-chart over here on the side. When we start looking for our factors of negative 18, we're going to see numbers like 1 and negative 18, 2 and negative 9, 3 and negative 6. 4 doesn't go in, 5 doesn't go in, and by the time I get to 6, I'm going to start repeating factors. So I'm going to add those up real quick, and I'm going to see 1 plus negative 18 is negative 17. And 2 plus negative 9 is negative 7. And 3 plus negative 6 is negative 3. And so, of course, this first one doesn't work for us because that's not what we're looking for. And the second one doesn't work because that's not what we're looking for. But the third one works perfectly well. 3 and negative 6 are going to be the factors we need to use in this particular question. We're going to go ahead and set up our parentheses. We will build our x squared with an x times x. And we will build our negative 18 with a plus 3 and a minus 6. Hopefully you got that question right, because now we're going to move on to something just slightly different. So one final situation I'd like us to look at is the situation where we have a negative number as that middle term, something like, let's say, a negative 6 there in the middle. And then on the outside, over here where our constant goes, we have a positive number. So our procedure is not going to change at all, but the way we have to think about it might change just a little bit. Let's go ahead and throw that constant term, that 8, right up there in our t-chart. We are going to, of course, create some factors for 8, something like maybe 1 times 8 and 2 times 4. But what we're starting to notice already, as soon as we look at our t-chart, is that these things are adding up to positive numbers. But our middle term here, our linear term in this case, is actually negative 6. So what can we do here? What can we do to create a negative middle term and still have a positive final term there, a final constant? Well, the answer again is pretty simple. If we know that the rules for multiplication tell us that a positive times a positive equals a positive, and a negative times a negative equals a positive, then we know that besides 1 and 8, there's also the factors negative 1 and negative 8, because negative 1 times negative 8 is going to give us positive 8. And besides the factors 2, 4, we have the factors negative 2, negative 4, because negative 2 times negative 4 gives us a positive 8. And that's very helpful here, because when I add up these factors, I see that we actually get the negative 6 we were looking for. It's right there. The factors are going to be x minus 2 and x minus 4. And that's it. That's the basics of factoring. We're going to create our t-chart. We're going to look for all the possible factors. And we're going to add up those factors and see which of them ends up being equal to our middle term. So I'd like you to take a couple moments right now. Our video's over. But I'd like you to take a couple of moments to answer a couple of questions about factoring, just to see how you're understanding. And of course, tomorrow in class, we'll walk through some other situations, and we'll have some time for some questions and some answers if you haven't quite got this. But I'd like to see where you are right now. So take a couple moments, answer the couple questions that follow this video, and then have a